Something is wrong. We may have to revise our theory of the creation of the universe.
For centuries, humans have been fascinated with the mysteries of the universe, and the burning question on everyone's mind is, what lies at the edge of the universe? The answer to this question has eluded us for so long that we have almost given up hope of ever finding out. However, the arrival of the James Webb Space Telescope has changed everything. Recently, the JWST made an astonishing discovery at the edge of the universe that has sent shockwaves through the scientific community. The discovery is so significant that it has the potential to shatter our understanding of the universe as we know it. Are you curious to know what the JWST found at the edge of the universe? Join us as we delve into the exciting world of astronomy and discover what this new discovery means for the future of science. Have you ever found yourself in the frustrating position of wanting to undertake a task but lacking the proper tools to do it justice? Imagine, for example, attempting to tinker with your smartphone only to realize you don't have the precise instruments necessary to crack it open, or desperately needing a flamethrower to complete a task but not having access to one. Scientists have faced similar dilemmas for centuries, particularly when it comes to unraveling the mysteries of the universe. Among the many puzzles they seek to solve is the question of how the universe itself began. Unfortunately, this requires equipment that is far beyond anything ever created by humans. It's necessary to view the edge of the universe to study some of the oldest objects and formations in existence, some of which have been around for billions of years. But don't despair, because the James Webb Space Telescope is here to save the day. The JWST is the most powerful telescope ever created, and its capabilities have revealed astounding new insights about the universe that have left scientists reeling. It has taken us back in time to glimpse the early universe and brought us closer to the edge of the universe than ever before. Now, thanks to its ability to detect infrared light, the JWST has given us an image of a galaxy cluster and a distant galaxy called MAX 0647 JD. That has thrilled scientists around the world. The cluster appears as a dazzling grouping of galaxies that sparkle like gems against the backdrop of space. The distant galaxy, which was originally discovered a decade ago using the Hubble Space Telescope, is now being studied in much greater detail thanks to the JWST's triple lensing effect, caused by the phenomenon of gravitational lensing. Scientists are still puzzling over whether these are two galaxies or two clumps of stars within a galaxy, but they're banking on the JWST to provide the answers. The image has allowed astronomers to better understand how galaxies evolved in the early universe and has challenged everything we thought we knew about the cosmos. Galileo Galilei, the father of the telescope, would surely be proud of how far we have come. And the JWST has gone above and beyond, discovering galaxies that are beyond our wildest dreams, and not just any galaxies, but some of the most ancient ones ever to exist. These include Glass Z12, which was captured just 350 million years after the Big Bang, making it one of the earliest galaxies formed. The JWST also found another galaxy formed 450 million years after the Big Bang, just a hop and skip away from Glass Z12. Previously, the earliest galaxy observed was GN-Z11 by the Hubble Space Telescope in 2016, which existed only 400 million years after the Big Bang. As scientists sifted through the data collected by the JWST, they were amazed to discover that there were even more galaxies in the universe than they had anticipated. It seems that the universe churned out galaxies at an unprecedented rate, faster and earlier than researchers had imagined. And the JWST gave us a front row seat to all of it, helping us better understand the origins of our universe. Although both Glass Z12 and the other galaxy are small compared to the Milky Way, they are incredibly bright and produce stars at an astonishing rate. It has been suggested that galaxies may have started appearing just 100 million years after the Big Bang, defying astronomers' previous theories about when and how the first galaxies formed. But the biggest mystery of all is how these early galaxies managed to maintain a sense of order in the midst of the chaos of the early universe. Despite the universe being a crowded and hectic place at the time, Glass Z12 and its companion were surprisingly peaceful and structured. Now, you might think you've already been impressed by the two distant objects mentioned earlier, but there's even more to marvel at, like the Sears 93316 galaxy candidate. This object formed a whopping 250 million years after the Big Bang and made history by setting a record redshift of Z equals 16.7. SEERS stands for Cosmic Evolution Early Release Science Survey, a special program specifically designed for imaging with the JWST. Scientists are currently in the process of confirming the redshift through spectroscopy, which is why they still refer to it as a galaxy candidate. However, based on imaging data from the JWST's primary imager, the NIRCam, the study has already ruled out the possibility of Sears 93316 being a low-mass star or an unobstructed active galactic nucleus. What's really exciting is that these observations push us back to the time when the first galaxies in the universe were thought to be forming, during what's known as the Dark Ages, a time before any of the stars we see today even existed. NASA has said that the JWST is capable of detecting galaxies at redshifts greater than 20, which corresponds to less than 200 million years after the Big Bang. Admittedly, these galaxies will be extremely hard to spot, but with the detection of Sears 93316, scientists are hopeful that they may exist. This is why the Sears 93316 discovery is so groundbreaking. It opens up a whole new realm of possibilities for what else we might be able to discover in the universe. Now, at the very edge of the universe lies a galaxy that got scientists buzzing with excitement. It's called Able 2744Y1. This extraordinary galaxy is remarkable for a multitude of reasons. One being that it is so far away from us that the light from it takes a staggering 13 billion years to reach us. That's almost as old as the universe itself, estimated to be 13.8 billion years old. What's more, we're seeing Able 2744Y1 as it was when it was only 650 million years old. But don't be fooled by its youth. This galaxy is a force to be reckoned with. It was discovered using three powerful telescopes, the Spitzer, Chandra, and Hubble, which worked together to collect data from various wavelengths of light. This enabled astronomers to see galaxies up to 100 times more distant than any of the observatories could have done individually. The team also used gravitational lensing, a phenomenon predicted by none other than Albert Einstein, to capture an image of Able 2774Y1. So how big is this galaxy? It may be small in size, about 50 times smaller than our own Milky Way galaxy, but it more than makes up for it with its incredible rate of star production. In fact, it generates stars at a rate 10 times faster than the Milky Way, which is typical of galaxies in the young universe. The exploration of this incredible galaxy is sure to keep scientists busy for years to come. Imagine trying to measure the size of the universe. Well, scientists have given it a go, and they have discovered that the observable universe is a whopping 46.1 billion light-years in radius. But we know there is much more out there beyond the observable universe, and we can make references about it based on what we can measure with our observable universe and the laws of physics we know. Observations suggest that the universe is spatially flat on the largest scales. This means that it's neither positively nor negatively curved, with an incredible precision of 0.25%. By using this knowledge and the best data from sources like the Sloan Digital Sky Survey and the Planck satellite, we can extrapolate the size of the universe beyond the observable part. If the universe does curve back in on itself and close, the unobservable part must be at least 23 trillion light-years in diameter, containing over 15 million times the volume we can observe. However, some scientists argue that the unobservable universe should be even bigger than that, as the hot Big Bang might have only marked the beginning of the observable universe and not the birth of space and time itself. This is because the universe underwent a period of cosmic inflation before the Big Bang. During this period, the universe was not filled with matter and radiation, but with energy inherent to space itself. It expanded at a constant exponential rate, creating new space so quickly that the smallest physical length scale, the Planck length, would be stretched to the size of the presently observable universe every 10 raised to the power of -32 seconds. Although inflation stopped in our region of the universe, there are still 3 key unanswered questions that directly affect the size of our universe. These questions revolve around whether the universe is infinite or not. Specifically, they are 1. How big was the region of the universe post-inflation that created our hot Big Bang? 2. Is the idea of eternal inflation, where the universe inflates eternally into the future in at least some regions, correct? And 3. How long did inflation go on before its end and the resultant hot Big Bang? While it is possible that the universe where inflation occurred barely attained a size larger than what we can observe, there is also a possibility that evidence for an edge to where inflation happened will materialize in the future. However, it's equally possible that there are numerous other universes out there, just like ours, that follow the same laws of physics and have similar physical structures. This raises the tantalizing possibility of complex life existing in one of the many worlds out there. Additionally, there should be a finite size in scale to the bubble in which inflation ended, with an exponentially massive number of such bubbles contained within the larger inflating space-time. Traveling to the far reaches of the universe, we arrive at the most distant galaxy ever spotted by humans, GNZ11. This celestial beauty is located a staggering 32 billion light-years away from our planet. If we account for the expansion of space, we reach a mind-boggling 46 billion light-years away from Earth at the surface of last scattering. This is where the first photons of cosmic microwave background radiation emerged after recombination and photon decoupling. It's the birthplace of the very first scattering of light, the edge of the universe, so to speak. It marks the boundary of what we can observe, forming the edge of the observable universe.